Okay, let's take you through this problem using an online Gaussian elimination calculator, the URL to which I will post on the final answer. So if you visit this site, you can change the names of the variables. They start out at x sub 1, x sub 2, x sub 3. You can choose the number of equations in the system. I changed these to x, y, and z, and then I entered the coefficients for the three equations, and including the negative out 8, 25, and negative 2 out to the right. If I visit board 2, this is what's called the augmented matrix right here. Okay, so these are the coefficients of x, y, z, and this is what the equation equals. I have to use substituted particular values for x, y, and z. Our goal is to perform elementary row operations on that augmented matrix and end up with something that looks like this, where we have ones along the diagonal and zeros everywhere else. And that will allow us to conclude that x is 6, this is y is negative 5, and z is negative 4. Those are the numbers that make this system true. This is called reduced row echelon form. And you probably have this on your calculator, RREF. Without the row, the first R, it's called row echelon form. Reduced row echelon form just lets you look at the matrix and figure out what the answer is. So what are the idea is to get a 1 in this first position in the first row. We already have that. The things that you're allowed to do to the matrix are to divide any row by the same number. You can multiply a row by a number and add it to another row. And that's what we're going to do here. We want to start by getting zeros here and here. And this 1 is going to allow us to do that. If I multiply the first row by negative 4 and add it to row 2, this 4 will become a 0, and these other numbers will change. Likewise, if I multiply the first row by negative 1 and add it to the third row, I'll get a 0 here. Let's see what happens. Here's the matrix, augmented matrix, and here's the notation that we frequently use to indicate what the elementary row operations are. We're going to multiply row 1 by negative 4 and add it to row 2. And that'll make this 4 become a 0. And you can see that's what's happened. If I take negative 4 times this 2 here, it's negative 8. Added to the second row is negative 9. Negative 4 times 1 is negative 4. Added to here gives us a negative 3. Negative 8 times negative 4 is 32. Added to the 25, this is 57. And by the same token, I'm going to multiply the first row by negative 1, add it to row 3, giving me a new row 3. So this is the kind of notation you use to specify your elementary row operations. Now that we've got zeros here, our next goal is to get a 1 here. And I can do that just by dividing every element of this row by negative 9. And that's what you're going to see on the next board. Here's the matrix that I had on the previous board, and I'm going to divide row 2 by negative 9. And these are the new elements here. And now that I have a 1 here, I can use this as the row that I multiply by to make this element and this element equal to 0. I'm headed along the right path. And the fact that I have zeros in the first column for the second row means I won't change the value of the 1 here that when I add to row 1. So here we go. I'm not going to go through every operation now, but this is what's happening. I've now got zeros here and here. And now I want to get rid of this negative 14/3. By that time, I'll have 1s all along the diagonal and zeros in the lower triangle. So here I've divided by negative 14/3 every element of the third row. And I'm getting close. The only thing I have to eliminate now are these 1/3. By the way, this is row echelon form. I could use back substitution at this point. This tells me right now that z is -4. So I could put -4 in for z in the second equation and solve for y. But if I want to use reduced row echelon form, then I have to get these two elements equal to 0. And I do that by multiplying the third row by -1/3 and adding to the second row, by -1/3 adding to the first row. And there is reduced row echelon form. I can tell that x is 6, y is -5, z is -4, and here's a check. Okay, so that's the idea. You want to get zeros here, then you want to turn this to a 1, get zeros here and here. Finally, get this to a 1 by dividing, and as you can see, we ended up getting these equal to 0 also. Okay, so that's the basic idea. Hopefully that gives you some idea how to proceed, and I will post the URL to the online tool in my answer.